Today we will continue talking about how we compare tests. And as you can see, here's the beautiful ID Now machine by Abbott. And the goal is to do rapid testing for the coronavirus, but actually this is nothing new. There's always been rapid testing requests for many other things. For example, strep throat, flu. Can you imagine going back today when you have to wait days for these results? Well, yeah, it wasn't too long ago, but now people don't have the patience to wait. Plus, we're trying to use people who are less trained. Not everybody can do these fancy tests. Sometimes you need nurses, sometimes you need, people to draw your blood. I mean, have you ever tried to draw somebody's blood? We did it in medical school. It went very poorly because we don't know how to do it, even though we're doctors. So today is an introduction manual, a textbook, some background about rapid testing. And we'll be able to learn something that's relevant to the coronavirus testing by looking at the case of strep throat. So a quick review, there's different ways of testing. I use a picture of the coronavirus, but there's testing for the actual presence of genetic material, because you presume this had to be present for all this outside stuff to form. Chicken and the egg is not the question. Obviously, this came first, though, what really came first, who knows. But the idea is you test the RNA versus you test for antigens, all these proteins on the outside. Here's a picture. If you didn't look at the other titles, what would you guess this is for? This is for strep throat. Should you consider a home test kit? Well, a little bit later, will we have a home test kit? Looks exactly the same. And there's a lot of things we could learn. So this is from the Cochrane Review. Cochrane's sort of organization that puts together good quality reviews, looking through lots of studies about strep throat. The reason is strep throat is most commonly viral. However, it could be a bacteria that's called Streptococcus pyogenes, group A strep. And most cases are fine, but if it's not fine, you could get scarlet fever, rheumatic heart disease, and we don't really want people to get that nowadays. We think of that as an old disease, sort of eradicated. We also don't want to use antibiotics too much. That's because most of the cases of pharyngitis where you have a sore throat are not actually caused by strep. So that's why they developed testing. So this is a short diagram of how testing works with immunoassays. So the idea is that you have antibodies and you have this sort of antigen. This is your thing of interest. And so your antibody can link it directly and have a sort of signal on it, or you could actually link an antibody and have other sort of antibodies to this antibody that has a signal. It's called direct versus indirect. Direct is, you would say, better, but this is actually cheaper because this one could make link to this one, and this one sort of could have sequences that are easily reproduced. So let's go through an actual example of how these work. So you put it here in your well. And then after you put it in the well, you have all these little things there, right? Including your antigen, maybe some virus particles, some other particles. And they go through quite a few things. And so these are things that it may activate when, it gets bound to a particular antigen. And then you come on to your antibodies. And here, they'll get attached if they have the region of interest or the antigen. And then so it'll actually light up. However, there's something called a control line. And so the idea is the control always lights up to make sure it's going correctly. And so at the very end, they'll actually show you what the result looks like. So this is called lateral flow immunoassay. And so this is the antibody on the sort of surface which cannot move, and this is your antibody that can move, that's bound. And so here's your well, and this is where it's moved, and you have all these colors, right? This is a negative, because this is your control. It's going to light up no matter what. If that doesn't light up, it doesn't work. It's not a good test. So let's go review again. So the idea is that we have basically a type where you have your little something bound on the surface and your antibody comes over and attaches and it has its own signal. That's what an immunoassay is. So in this case, we'll have a virus particle and it has a sort of, whether it attaches or not, if it attaches to something, it'll light it up. So in terms of the rapid strep throat, they did quite a few studies on these. These are all decade or few decades old. And they actually found a lot of things that are relevant to how your test performs. So one is your inoculum. How much do you actually have there? And if you look, the higher you have, the better the rapid test. This is rapid antigen detection test, right? And this is the culture. The higher you have here, the better it performs. See, 17 versus 25%, 20 versus 24, but you get higher and they're sort of about equal. So that's one thing important to know is how much of this virus do you have, this coronavirus? If you have more, then the rapid tests are probably good enough, even if they're not the best. If you have less, then maybe, yes, they could miss some stuff. And actually, the Cochrane study is very interesting. If you look at these sort of ranges, I know the font's really small, but they actually found that the sensitivity ranged from 38.6 to 100%. So there's quite a big variation on which test. This is about one specific type of test. And this is another test where they actually compare nurses versus technologists, I guess is the proper way we say them instead of technicians. But they compared how they did their testing to see if there's a difference. And lo and behold, there is a big difference. The sensitivity of this is not too different, of this is not too different, but this is very different, right? 39, 72%. So apparently the person performing it matters as well. Why? Let me read you from the sort of old study how to perform it. Strep A optical immunoassay technique. Following the manufacturer's instructions, the swab is extracted into 0.3 molar acetic acid for 2 minutes. The extraction was neutralized and a labeled antibody was added. The sample was subsequently placed on the OIM membrane for a 2-minute incubation. The next step was a rinse cycle. The final reagent was a substrate, which was added in the incubator for 4 minutes. After one more rinse, a color change of purple was interpreted as positive, and a gold color with a procedure control dot was interpreted as negative. So I did read it pretty fast, but it's pretty complicated, and let me show you how it works. This is by DrSean. This is the D for DrSean. This is a different test, but this is their flu test. But look, which one's positive, which one's negative? So this is negative, this is positive, this is still positive because you still see the triangle. You see? Can you make out the triangle? Right? Pretty complicated, right? Let me give you another one. Okay, this is like the one we showed, right? So this is like the one that, the lateral flow, that they had this pretty animation. But, in real life, it looks something like this. Okay, is this, it's faint. Do I need to turn up the light for this? It's pretty hard to see, right? And then this one, latex occlusion, we just don't use very much. This is one of the ones that one nurse had a lot of trouble reading. But which one's positive, which one's negative? Well, you have to look closer. You have to look at this beaded pattern. If you have this beaded pattern, it's positive. Okay. There's also a difference in the study that they were showing here. And that's that one, the nurses test differently than the technologists. So the techs batch it. So they moisten it, they put it in a storage medium, and they test it every hour. The nurses do one test, run it right away, come back, do another test, run it right away, where the techs do a bunch of tests and then run it all at once. Is there a rule? No, I don't think so. Yeah, they didn't say whether or not you could do it one way or the other. There's actually a difference though. When the people didn't run it right away to text, they would actually moisten the swabs. They put in some medium. And that actually made a difference to how the result turned out. This is not described in the details of the instructions. They're both technically doing correctly, but we just know one way is better than the other, but this was never explained. And the irony is that actually both the nurses and the techs all had training on doing this before. They actually did it. They did 10 tests with people watching them. So this is a brief intro on how testing is actually very complicated. So there's the first of all design of the test. There's many different ways of designing an immunoassay. There's that indirect, direct, lateral flows one way. There's lots of different sort of technicalities. Depends on the people that do it, how well these people train. I'm guessing in many places now they're running out of trained staff, so you just give some layperson a little bit of training and you say you're good to go, right? And they just make up their rules as they go along. And then there's always trade-offs with time and money. That's the thing. Time and money, right? They always matter. We may pretend they don't matter. We have infinite resources, but we don't. So culture, PCR, those are all better things. Culture in the case of group A strep, right now they're trying to do virus culture. I don't think they're very good at it yet, so we can't really use that too much. But the idea is rapid point tests aren't as good as the ones run in a big lab that take a day or two to come back. But they're not meant to be, and they're all about trade-offs and how much you could accept. As we've seen, if people have a lot of virus, yeah, we could probably catch it. If they don't, we may miss it. How important is that? Well, I don't think that's a decision made by the test company. The test, they give you a test. It's like a driving test, right? It's like tests for, SAT, all these tests we take for school. You get a number, and it's up to somebody else to determine if that's a good or bad number, right? If you get a 1600 on SAT, that's a wonderful number. For Harvard, average, right? So it all depends. And the idea is that tests are made by test companies. They're supposed to tell you all the details about the test, in what cases they work well, in what cases they don't. And people who actually make decisions, the doctors, the government, the policymakers, they should determine whether or not this is the appropriate test. There's many tests to choose from. And the next talk we'll talk about specifically regarding coronavirus antigen testing and this company called BioEasy. That's the company that's reported in Spain to have very low sensitivity. But today is just sort of a background in talking about testing, using an example of strep throat, which most people know what it is.